In the last video, we have seen which folders and files will be generated from a given grammar by MontiCore. In this video, I want to take a closer look at the tool workflow of MontiCore. I'm going to use the automaton example grammar again. In the source folder of the example, there's a Java file called automatontool.java, which is the main class of the automaton DSL. It defines the automaton tool's main control structure. I'm not going to go into much detail on the methods used, but will give you an overview about the workflow. More details on the specific methods can be found in the corresponding videos. First thing you might recognize is that there are a lot of imports. The class imports I/O exceptions and optionals, as well as another exception type that we need for the ANTLER parser generator. All other imports are either basic MontiCore imports or imports specific for the automaton DSL. This main class has to be called with exactly one argument, which is the path to an automaton input model. After the model is identified, the parser automaton parser is used to parse the model. This results in an AST object, which identifies the internal structure of the model. This step, as well as most of the following steps, will be written into the log file. Based on the AST, the symbol table is created afterwards. In the following, the symbol table is used to resolve things in the model. Here we see an example resolution of a state symbol. A parser can only identify context-free parsing errors. However, the DSL might have also defined context-sensitive constraints that have to be validated. In case of the automaton DSL, one such constraint might be that all states have to start with a capital letter. But first, the tool checks some default context conditions. Next, an automaton COCO checker object is created, which can be configured with concrete context conditions like the one I stated before. This context condition obviously has to be implemented by a developer in the corresponding class. The checkAll method will then check every context condition that has been registered before. Now we know that the model is well formed. In the following, the model will be analyzed with a visitor. Visitors provide a decent infrastructure to traverse the AST and perform actions on it. In the first case, the number of states is calculated. Finally, in the second case, the model is pretty printed. Pretty printing serves multiple purposes. On the one hand, the resulting model may be easier maintainable or simply stored as documentation. On the other hand, pretty printing helps to check whether parsing and the AST construction were correct and complete. This was the last step of this workflow. In the bottom you can see 3 additional static methods. These are used for the 3 main steps. First, parsing the model. Second, creating the symbol table. And third, running the default context conditions. This example only covers the essence of working with an implemented DSL. There are many other possibilities which are covered in the corresponding videos, as well as in the MontiCore reference manual.